analysis today, and nodal analysis, what we are doing is we are actually using the nodes to find out different voltages. Okay, so basically what happens is, say if you're talking about a particular circuit over here, in this loop you're having one battery source E1, and in this loop you're having one battery source E2. You're having three resistances R1, R2, and R3, and we're just assuming some currents are flowing. So this is I1, this is I2, and this is I3. Okay, fine. Now the node which is connected to the battery, we assume that node is having a voltage of whatever the voltage the battery is giving. That means the voltage of A is 120. Likewise, the voltage of C will be 65. So we are getting the voltages at these nodes, but we don't know the voltage of this. Okay, so the voltage where means of those nodes which we don't know are the independent nodes. Okay, and these are the dependent nodes. And one node we take to be the reference node, say 0 voltage. Okay, one node we take to be the reference node, and in general the reference node is the bottom line where no resistances are there. Here can be a resistance also. Here can be a resistance also, but we are assuming there is, in maximum cases, you will see there are no resistances over here. So basically, this node we are taking to be the reference node. So B is the independent node because we don't know the voltage. A and C are the dependent nodes where the voltages are just the voltages the batteries are giving. So what we have to do is we have to find out the voltage of this node, or independent nodes rather, okay, because there can be two nodes also, two independent nodes. And we have to use, for finding out the voltages, we have to use obviously Kirchhoff's current law, since we are talking about a point over here, not a loop. And whenever you find out the voltages of the nodes, you will see that you will see that it is easy to find out, or even you have to find out the currents, and obviously you have to find out the voltages, and you will see that finding out the voltages at the independent nodes, will give you the current also, means it will be, you can find out the current also. So what are the process, or what is the procedure, how we will just move on? Say in this circuit, see, P is independent node. We have assumed I1 coming to B, I2 going out from B, I3 coming towards B. So at this independent nodes, just apply KCL. If you just apply KCL, obviously I1 plus I3 will be equals to I2. Now, if you are having a voltage at A, which is 120 volt, obviously, you will not be having the same voltage at B because there will be a voltage drop in this resistance. Likewise, if you are having a voltage 65 volt at C, obviously with respect to C, you will not be having a voltage drop in the same voltage over B because there will be a voltage drop. Okay. So this is the current law. This is Kirchhoff's current law we are having, and then if you are talking about say this mesh, obviously the voltage drop across R1 will be E1 minus VB by R1. E1 means the voltage at A minus the voltage at B. We will do minus from where the current is going. A minus B, okay, VA minus VB, and VA is 120 volt, that is E1. E1 minus VB divided by R1 is the current I1. Likewise, 65 minus VB divided by R3 will be the voltage drop over this, sorry, 65 minus will be the voltage drop over here, and if you divide by R3, you will get I3. So this is I3. Finding out I2 is very easy because V we have taken to be the reference voltage, which is 0 we are assuming. So basically, since I2 is going downwards, so VB minus VD, since VD is 0, so that means simply VB by R2 will be I2. Okay. Now you put the values of I1, I2, I3 in the KCL law, which you have written, and you find the equation, and in this equation, see only VB is unknown, else everything is known to you. So once you can find out VB, you can find out all the currents in all the branches. Is this clear, everybody?
স্যার আর একবার একটু বোঝাবেন
কোন জায়গাটা?
ওই যে মাইনাস করতে বললেন একটা থেকে আরেকটা।
মাইনাস করতে বললাম।
আচ্ছা, বুঝতে পেরেছি স্যার। ওই রেজিস্টার ওখানে তো মানে কিছুটা কারেন্ট মানে ড্রেন আউট বা
এইখানে
ইউজ হয়ে
এখানে
যাচ্ছে।
হচ্ছে এখানে হচ্ছে এখানে হচ্ছে VA, এখানে হচ্ছে VB. At node A, it is VA. At node B, it is VB. So what will be the potential drop over here? VA minus VB. This is the potential drop. Always the potential drop is taken along the current. Along the current means obviously since the current is flowing from A to B, as we have assumed. Okay. So A is at higher potential and B is at lower potential. So we will be just subtracting VA minus VB. If the direction of current was in this way from B to A, then obviously it should be VB minus VA.
আচ্ছা,
This is the potential drop over here. And potential drop divided by the resistance is the current I1. Is this clear?
yes sir.
Potential drop VC minus VB is the potential drop at R3 divided by the resistance R3 will be the current I3. Potential drop VB minus VD, this is the potential drop over here. Since VD is 0, we are not taking this one. Divided by R2 will be the current I2. Is this clear now?
হ্যাঁ
স্যার
স্যার
আবার বলে দিন না।
এখানের পটেনশিয়াল ড্রপটা কত হবে? R1 এ কতটা পটেনশিয়াল ড্রপ হবে? What will be the potential drop over here?
স্যার আর 1 আর 3 টা বুঝতে পেরেছি, তবে আর 2 মাঝখানে কি বললেন বুঝতে পারিনি, কারণ কারেন্টটা চলে গেছিল, নেটওয়ার্ক পড়ে গেছিল।
R2 হচ্ছে একই জিনিস VB minus VD. VD is the reference node. Reference node এর পটেনশিয়ালটা আমি 0 ধরি। তার মানে এখানে আর VD এর পোরশনটা থাকছে না। We don't have VD over here. So that means only VB by R2 that is equals to I2.
ওকে স্যার, এবার বুঝতে পেরেছি।
So simple thing, the number of independent nodes equals to the number of equation we will get. Again, we can write in terms of conductance. আমি এটা পাঠিয়ে দেবো, চিন্তা নেই। We can write in terms of conductance. Okay, means instead of writing R, we can write G. We know 1 by R equals to G. Okay, G is the conductance. So that means I1 will be E1 minus VB by R1. That is equals to E1 minus VB into G1. I2 will be VB into G2 likewise, and I3 will be E2 minus VB into G3. Using conductance means you can get sums using conductance also instead of resistance. So be very careful whether it is given resistance or conductance. Okay, and we will be using conductance. We will be using conductance to use the shortcut method, just like the mesh analysis. Okay, clear? আজকে শুধু নোড অ্যানালিসিসটাই পড়বার কিছু না। আমি জাস্ট কয়েকটা অঙ্ক দেখাবো আর নোট অ্যানালিসিস করাবো। Now you see, let us come to two independent nodes.
স্যার ওই একটু লেট হয়ে গেল, আসলে অন্য জায়গায় পড়া ছিল, ফিরতে একটু দেরি হয়েছে, ওই জন্য লেট হলো।
আচ্ছা আচ্ছা ঠিক আছে,
স্যার
দেখ
1/r equals
একটু
to
নোট
কি?
অ্যানালিসিস করছি। Now we see
স্যার
two independent nodes. হ্যাঁ বল।
1/r equals to কি লিখেছিল?
G conductance. So we have E1 over here, which is connected to the node A, which is passing through R1. Then we are having B. Then we are having one E2 connected to R2. Then we are coming to C, the node, and then again a resistance. Then we are coming over here. এই কানেক্টটা আমরা আর কিছু লিখছি না, you can name it. Okay, obviously এখানে দেয়নি, কিন্তু you should name it. And we are having one D and we are having one E. So in this case, there is no resistance over here. And since E and D are shorted, shorted means it is directly connected without any resistance over here. That means the potential E and the potential D will be same. So that means we will be having now two reference nodes, which is E as well as D. If you take D to be the reference node, that means E itself will be a reference node. If you take E to be the reference node, then obviously D itself will be a reference node by default.
আচ্ছা
Okay, clear? Okay, so
স্যার বললেন আর একবার বলবেন, মানে ইটাকে ধরলে ডিটা কি বললেন, ওটা শুনতে পেলাম না ঠিক।
if you take E to be the reference node, by default D will be also the reference node because it is connected directly. There is no resistance, no battery, nothing is over there. E আর D এর potential তো same হবে, direct যদি connect করে দিস দুটো পয়েন্ট, তাদের দুটো potential তো same. If you connect
হ্যাঁ
two
স্যার।
points directly, be aware the potential of those 2 points are always same. So if D you are taking to be the reference node, by default E will be also the reference node.
একদম।
So independent nodes, obviously if you are talking about this node, কোনো নাম দেওয়া নেই, but still if you are talking about this node, this will be dependent node, A will be independent node. সে আমি এটাকে একটা নাম দিয়ে দিচ্ছি, তোরা একটা নাম দিবি obviously. Say F. F is the dependent node, A is the dependent node because those are connected directly to the battery. E and C we are assuming to be independent node. You can ask sir, এটা তো ব্যাটারির সঙ্গে connected আছে, but though it is connected, you have a resistance on either side of B. So the potential at B and potential at A or the potential at C will not be equal because though there is a battery, there is a resistance too. So B and C are the independent nodes. Now we will be using Kirchhoff's current law at B and at C. So Kirchhoff's current law states that I1 is coming, I1 plus I2 equals to I4. I1 plus I2 equals to I4 at node B. And at node C, I3 equals to I5 plus I2. I5 and I2 are going out. So I2 plus I5 equals to I3. So we have written the Kirchhoff's law. Now you have to find out the currents in terms of the voltages. So I1 will be E1 minus B, E1 minus BB by R1. That is I1.
VB by
I3 will be E3 minus VC, E3 minus VC by R3. E3 minus VC by R3. Okay, I'm coming to I2 at last. Then come to I4. Since E is the reference potential, so I4 will be simply VB minus R4. See, VB minus R4 is I4. And then come to I5. D is the reference potential. So VC by R5 is I5. VC by R5 is I5. Last come to I2. I2 obviously it would be easy if there is no sources over there, but one source is present over here, right? And we have assumed the direction of the current to be like this. Which way? This way. Okay. So it will be VC minus VB obviously, and E2 will be added. E2 will be added because we are going to the direction as it is from positive to negative obviously. So E2 minus VB plus VC by R2. See, VC minus VB we are getting, E2 will be added, divided by R2 will be I2.
স্যার আইটুটা বুঝতে পারলাম না, একবার রিপিট করবেন?
VC থেকে VC VB যাচ্ছি, তাহলে VC minus VB, simple thing, VC minus VB, and we are getting going towards from negative to positive, so E2 will be added. Positive থেকে negative হলে E2 that subtract হবে,
হ্যাঁ,
E2 will be added.
ওকে স্যার।
So VB minus VC plus E2, এটা rearrange করে লেখা আছে, it is written E2 minus VB plus VC
হুম,
by R2, and that is equals to I2. So we have all the currents. We will get two equations, and in these two equations there are two unknowns which are VB and VC. Solve it either by simultaneous linear equation or through matrix method. You can write in terms of conductance also. Writing in terms of conductance will be very easy for you to solve, because in these equations, if you are writing in terms of resistances, see, everything will be in fraction. If you write in terms of conductance, there are no denominators. Hence, calculation will be easier for you. I suggest to write everything in conductance. বোঝাতে পারলাম? समझ में आया? বোঝা গেছে সবাই?
হ্যাঁ স্যার।
Any question you want to ask? Anything you can ask.
আচ্ছা, উপরে সার্কিট একবার দেখান স্যার, ওটা কপি করি, ওটা লিখি।
লেখার দরকার নেই, আমি সব পাঠিয়ে দেবো।
আচ্ছা স্যার, ঠিক আছে।
Okay, fine. Now let us come to some problem. Okay, real problems, then it will be easy. This is the theoretical total part, how we will be doing this one. Okay, so a problem, a little bit easy problem is given. Easy why I say, because there is no battery between B and C. Okay, A5 কে পড়াচ্ছিলাম বলে এখানে এগুলো লেখা আছে, ঠিক আছে। Now let us find the currents in the various branches of the circuit and solve this problem right now. Okay, find the currents in the various branches of the circuit as shown in figure 3.22 by nodal analysis. Okay, fine. You have to you can find out currents by any method, but if it is mentioned, you have to obviously follow that one. Keep it in mind. So again we see over here A, B, C, D, E, F. There are 6 nodes. Out of the 6 nodes, what are reference nodes or nodes? Which one will be the reference node or node?
ERF স্যার।
Good. ERF are the reference node. What are independent nodes?
ইন্ডিপেন্ডেন্ট হচ্ছে আপনার
PNC,
B and C independent, and dependent nodes?
AND,
Okay, fine. What is the value of A, VA,
VA 100 volt,
and VT?
80 volt.
Fine. So basically 50% of the sum you have done. Okay. So current at B, I1 equals to I2 plus I3. I1 equals to I2 plus I3. What is I1?
I1 equals to sir
100
VA
minus 100 minus VB, right? 100 minus VB by 20 is I1. Okay. What is I2? VB by 10. VB by 10 is I2. What is I3? VB minus VC by 15. VB minus VC by 15 is I3, right? One star is given. in VB. Why the star is given? Note that the current I3 is assumed to flow from B to C. Therefore, with assumption VB is greater than VC. That reason. If we have taken the current direction of I3 to be opposite from C to B, what I told, it should be VC minus VB. If somehow you are getting the current I3 negative, that means actually it is flowing from C to B. Clear? Clear or not?
স্যার এখানে তো
বাংলায় বলছি যদি I3 টা মাইনাস পাস, তার মানে অ্যাকচুয়ালি এটা সি বি তে ফ্লো করছে।
আচ্ছা
আমরা যা ধরবো ডিরেকশন কোনো কারণে যদি পজিটিভ পাই তাহলে সেম যেটা ধরেছি সেটা ঠিক আছে, যদি নেগেটিভ পাই মানে উল্টো ডিরেকশনে ফ্লো করছে। এটা তো আমি আগেও বলেছি।
ওকে স্যার।
বোঝা
স্যার
গেল?
এখানে তো বি থেকে সি তেই ফ্লো করবে না?
সেটা ডিপেন্ড করছে, করে দেখি বি থেকে সি তে ফ্লো করবে কিনা। আচ্ছা, তো
আইপিটা কি করে বার করবেন একবার বলে দিন না। মানে
কি?
বি ওখানে বুঝতে পারলাম না, একবার রিপিট করে দিন। একটা তো বললেন 100 মাইনাস ভিবি বাই 20, তারপরেরটা ভিবি বাই 10।
I1 হচ্ছে 100 মাইনাস VB by 20, I2 is VB by 10, I3 is VB minus VC by 15.
ভিবি মাইনাস ভিসি বাই 15। আচ্ছা হ্যাঁ বুঝতে পেরেছি এবার।
And at node C, you are getting I3 equals to I4 plus I5, and I3 is the same thing, right? VB minus VC by 15. I5 you are getting sorry, I4 you are getting, first you do I4, I4 you are getting VC by
VC
10
by 10
and I5. Now I5 should not be VD minus VC. The direction of the current is this way. The direction of the current is this way. So it should be VC plus 80.
নেগেটিভ টু
It
পজিটিভ।
is not like this one. This is the opposite case. See, it is 100 minus VB by 20 is the current. Here it will be VC plus 80 by 100. Sorry, by 10 is the value of I5. You just put it. You can do this one in terms of conductance also. If you solve, you will get two equations. This is one equation, another one is this one. If you solve it, you will get the value. Even you can solve this one by determinant also. And why I say so, the value of I1 comes out to be 4.5 ampere. Okay, fine, very good. As we have assumed, the direction is same. I2 is 1.5 ampere, very good. I3 is 2.75 ampere, very good. I4 is minus 2.625 ampere. I5 is good, 5.375 ampere. Okay, the value of I4, what you are getting is minus 2.625, and this is what I said right now. That is I4. We have assumed this one, but actually it is flowing this way. Basically it should be I5 এখান দিয়ে এসে এটা নেগেটিভ থেকে পজিটিভ, this is negative to positive, so it is going up. Total I4 এর ওই ব্রাঞ্চে total current it is going up from F to C.
আচ্ছা
Is this clear? Very easy, very easy actually.
আচ্ছা তাহলে
Any
তো
question,
লাস্টে
anything?
লিখে দিতে হবে একটা কনক্লুশন বলে, যে কারেন্ট মানে I4টা এফ টু সি এফ ফ্লো করছে, নট সি টু এফ।
খুব স্বাভাবিক, তুমি মাইনাসে পেলে সেটা তো তোমাকে ডিফাইন করতে হবে না।
আচ্ছা
If you are getting the current in minus, obviously you have to define that one, the direction. No need of defining when you are getting in positive value. But if you are getting a negative value, obviously you have to define it. Okay, clear?
ওকে স্যার।
Now see, question in MCQ form. I4 is given, I4 is flowing Anyhow, it is given there is a branch CF where I4 is flowing. What will be the direction of I4? Four options are given. So basically, if you have to find out the direction of I4, you have to solve the total sum.
Clockwise.
Or a combination is given. I1, I2, I3, or I1, I2, I5. The values of I1, I2, I5 are first option given three values, second option given three values, third option given three values. You have to find out everything. Okay, got it? Clear? Understood? And if it is yes, obviously you have to write it. See, this sum, important sum, but easy. Just like the previous one, since E and F are the same potential, we are assuming those potentials to be equal, right? Reference potential 0. Even the sum is can be reduced to this one. Since this one, these three potentials are same, we are naming this potential to be 1, this one to be 2, this one to be 3, and these three are equal to 4. And we have redrawn the circuit over here, where this is total I. Now I1 is going here, I2 is here, I3 is here, I5 is here, I6 is here, I4 is here. This is 2 ampere, this is 10 ampere. There is no voltage source. Simple thing, node 1, node 2, node 3. There are three nodes, three equations. I1, if you are talking about node 1, I is going, I1, I2, I3 are going out. So I equals to I1 plus I2 plus I3. Now see, what will be I1? I1 will be, this is V1, this is the reference node, V1 by 2. See, V1 by 2. I2, V1 minus V2 by 3. See, V1 minus V2 by 3. I3, V1 minus V3 by 5. V1 minus V3 by 5, and that is equals to 10 ampere. So no need of writing in EMF also. You are directly writing in this way. There is no EMF, so in current form we are writing. We have the current, we are writing it down. We are solving it. Come to the second one. Second one, I2 is coming and I5 and I4 are going out. So I2 equals to I4 plus I5. What will be out I2? V1 minus V2 by 3. V1 minus V2 by 3. I5, V2 by 5. V2 by 5. I4, V2 minus V3 by 1. V2 minus V3 by 1. Solve it. You are getting the answer.
Okay, sir.
Okay. Lastly, node 3. Node 3, I4 is coming, I3 is coming, I6 is going out, and 2 ampere is going out. Keep it in mind.
I3 plus
I4 is coming, I3 is coming, 6 is going out, and 2 ampere is going out. Don't miss the 2 ampere. Okay. See, so that means I3 plus I4 equals to I6 plus 2. See, I3 plus I4 equals to I6 plus 2. If we know everything, you just put it, you will get the equation and solve it. And solving, you are getting V1, V2, V3, and from V1, V2, V3, you can find out all the currents. And obviously, current I1, I2, I3, these are all positive, and everything is positive. So everything what we have assumed, the direction, are right.
Acha.
Is this clear? The basic thing is we have to identify the nodes, independent nodes, write down the voltages or the currents in terms of voltages. Applying KCL, you just put the values of the currents and solve it. That's all. Any question you want to ask? Anything you can ask.
No, sir. Okay.
স্যার আপনি স্যার এই পিডিএফটা আজকে পাঠিয়ে দিলে সুবিধা হতো।
ওরে বাবা, আমি আজকে আমার সময় একদমই হবে না, আমি কালকে দেবো।
ঠিক আছে।
ঠিক আছে, আমি এই যে তোদের 8:30টায় করলাম, আমি 8টায় বাড়ি ঢুকেছি আজকে। ঠিক আছে, সেই সকালবেলা বেরিয়েছি, সকালে একটা ক্লাস নিয়েছি, নিয়ে বেরিয়েছি, 8টায় বাড়ি ঢুকেছি, ঢুকেই তোদের ক্লাস নিচ্ছি। ঠিক আছে, আমি চেষ্টা করবো কাল সকালবেলা পাঠিয়ে দিতে।
ওকে স্যার।
হুম, বোঝা গেল? ক্লিয়ার? এনি কোয়েশ্চেন, এনিথিং ইউ ওয়ান্ট টু আস্ক?
নো স্যার।
স্যার একটা করতে দেবেন কি এখন?
করতে কিছু দেবো না, বাড়িতে করবি। ঠিক আছে, একবার জয়েন কর, আমি একখানা ছোট্ট জিনিস ছোট্ট জিনিস একখানা দেখিয়ে দিই, তারপর শেষ করবো ক্লাসটা। আর একবার জয়েন কর ছোট করে, তাড়াতাড়ি, as soon as possible. আচ্ছা, দেখ, একটু খেয়াল রাখিস তোরা, হ্যাঁ? তারা আছে একটু অ্যালাউ করে দিস। ঠিক আছে, করে দিচ্ছি। আচ্ছা, এবার যেটা দেখাচ্ছি, ঠিক আছে, সেটা হচ্ছে আমাদের শর্টকাট মেথড। নাও we will see the shortcut method. Bhumi and Samiksha over there, right? Isn't it?
Yes, sir.
Yeah. Now we will show you the shortcut method. But in shortcut method, what happens is you have to calculate everything, or you have to write everything in terms of, okay, not resistance. And the values or the way how we have done the shortcut method in mesh analysis, we will be doing the same thing over here. Okay. See, these are the equations we are writing actually. These are the equations we are writing actually. VA, GAA, we have written in this way, right? Isn't it? R11, R12, R13, R21, R22, R23, R31, R32, R33. In this way we have written. Here also we are writing in the same way, but in terms of conductance. VA, GAA, VB, GAB, VC, GAC, that is equals to IA. VA, GBA, VB, GBB, and VC, GBC equals to IB. VA, GCA, VB, GCB plus VC, GCC equals to IC. This way we are writing. So obviously GAA, GBB, GCC, those are same. And what are those? Sum of all conductance connected to those nodes. Means if you are talking about A node, how many conductors are connected to A nodes, we will be adding. How many conductors are connected to A nodes, we will be adding. For example, if you come to this equation, if you come to this circuit, let me rub it first. So at A node, what are the conductances are there connected at A nodes? What are the conductance connected to A node? G1 and G2? একই না, সেটা তো বল। G1 and G2, that means GAA is G1 plus G2. GAA will be G1 plus G2. Okay. And the cross one, GAB. GAB means in between A and B, what direct conductance is connected. So between A and B, only G2 is connected. So G2 will be GAB. Got it? If you are talking about, and what will be this one? VCGAC. There is no such conductance. There is no such conductance connected between A and C directly, right? Is there any conductance? It is zero. So no question of having this term in the first equation. Is this clear? Understood? So what will be the second one? VA, GBA. VA, GBA. VA into GBA means G2. VB, GBB. VB, GBB. GBB over here will be G2 plus G3 plus G4. There are three conductance connected to node B, connected to node B, right? And VC, GBC. Obviously, VC, GBC is GC into G4.
G4.
Yes, that is equals to IB. Got it? Clear? Understood?
Yes, sir.
In maximum cases, what we will see is GAB equals to GBA, GAC equals to GCA, GBC equals to GCB. In maximum cases, is like this. See, the first equation what we are getting is this thing. The first equation. We are getting only two terms. We are not getting three terms. We are getting two terms. Don't go through the positive negative sign right now. Is this clear?
Yes, sir.
So the first equation we are getting only two terms. Okay. Now you come to the positive or negative sign. Direct notes which we are talking about means GAA, GBB, GCC, those are positive, else everything is negative. GAB, GAC, GBC, GBA, GCA, CB, everything else is negative. Accordingly, the equations, the left hand sides are written. Accordingly, the left hand sides are written. Hold on 1 second. Hold on. 1 minute hold for it. Okay. Acha. Let's come back now. So we are getting see VA, we are getting VA into G1 plus G2 minus VB into G2, that is equals to minus IA. Why we are taking minus? See, if current is leaving a node, then we will take that one to be negative. If the current is reaching a node, then we will take that one to be positive. Okay, and if we don't have any current, we will simply put 0. Over here we are having IA, IB, IC, right? So IA, IB, IC, if we look at the circuit, IA is going out of the node. Obviously, it will be negative. IB is coming to the node. Okay, IB is coming to the node. It will be positive. Okay, so in this way, and over in this node, in this connection, if we are don't putting any IB or IC, it will be simply 0. It will be simply 0. So accordingly, the first equation we are having VA G1 plus G2 minus VB into G2 equals to minus IA because it is going out. Similarly, for node B, if you are talking about node B, see there is no current, no I over here. So the right hand side will be 0 and the left hand side will be VB into the sum of the conductance. That term will be positive and cross direct conductances, those will be negative, that is equals to 0. And in case of node C, we are having again only two values or two terms on the left hand side and the right hand side. IB is going towards the node, we are taking that one to be positive. This is the easiest way to do that nodal analysis. And if you just go to a sum, this one, C, simple sum, this one, we are having A and B. Okay, so how we will solve? If we solve the equation, 2 ampere is coming out. Here also 2 ampere is coming out. So basically, we are having these equations VA. ছোট করে দিই একটু দ্বারা সার্কিট সময় দেখতে পাবেন। See VA connection at VA 0.01, 0.02. So those two are added. And VB, that will be minus since we are talking about this node. This will be minus. And only one connection is there in between A and B. So 0.01 into VB. And that is equals to, we are talking about this 2 ampere which is coming out, minus 2. Directly you can write the equation. Rearrange it. Likewise, if you are talking about this node, again, this 0.1 and this 0.01 is connected to B, so which will be positive, 0.01 plus 0.1 into VB. And this 0.01 is in between this A and B, which is negative, minus VA 0.01. And this 2 ampere is again coming out of the circuit of the point of the node. So that means it will be equals to minus 2. Write it, rearrange it. You have the two equation, you can solve it. Or else you can apply the KCL and you can solve it. Whatever, if you apply KCL, you are having the same thing. So this is the shortcut method. But be sure the shortcut method, resistances are given. You have to change everything in conductance, the values, and then you have to solve. Then you can do the shortcut method. Is this clear? Any question? Understood?
এখানে যেহেতু মানে মাইনাস সাইন আসছে, মানে যদি এ নোটটা নিই তাহলে বাকিগুলোর জন্য মাইনাস আসছে, তাহলে ফর্মুলাতে কেন মাইনাস দিচ্ছে না?
কোন ফর্মুলায়?
মানে যেটা একদম আগে দেখালেন ওটা।
সেটা প্রসেস, সেটা কোনো ফর্মুলা না। এই মাইনাস সাইন আসছে এই জিএবি এর জন্য, ঠিক আছে? জিএবি টা কানেক্টেড, সেই জন্য এইটা হচ্ছে প্রসেস। অ্যাকচুয়ালি উই আর অ্যাডিং অ্যালজেব্রিক্যালি, এই ফর্মুলা মানে এটা হচ্ছে প্রসেস, হাউ উই উইল রাইট ইট। দিস ইজ দ্য প্রসেস, these are not the formula, these are the processes how we will write it. মানে সেই জন্যই বলছি এ মানে sum of all the conductance connected to node A, তার মানে এই ক্ষেত্রে সেটা G1 plus G2, GAB মানে direct conductance, ঠিক আছে? এখন তোর যদি মনে হয় আমি এইগুলো মাইনাস দিয়ে লিখবি, সেক্ষেত্রে তুই IA, IB, IC সেগুলো তো মাইনাস দিতে পারবি না। ইজ ইট পসিবল? সেটা কানেকশন অনুযায়ী তোমাকে করতে হবে। IB, IC যেরকম দেবে তোমাকে সেরকম ভাবে করতে হবে। How the IB and IC will be given to you, whether it is coming out of the node or going through the nodes, accordingly you have to take signs, the positive or the negative.
আচ্ছা স্যার।
এর গুলো যদি মানে এখানে তো বেরিয়ে যাচ্ছে, ওটা যদি আহ
কারেন্ট গুলো ঢুকলে if those 2 amperes are
ওই পয়েন্টের
directions
দিকে
are
যাওয়ার
if the direction of the currents are in this way, that means the right hand side you are taking both to be positive in these two cases. That means you should be +2 instead of -2 in those equations. Understood? Clear?
হ্যাঁ স্যার।
If resistances are given, no need to redraw. Simply this resistance are connected to node A. Means here there will be a conductance, here there will be a conductance, here there will be a conductance. What are the conductances? 1 by 5, 1 by 15, 1 by 2.5. See, 1 by আচ্ছা 1 by 5, 1 by 15, 1 by 2.5, right? আমি বলছি এখানে একটা নেওয়া হয়নি কেন পরে বলছি, I am saying it afterwards. Now if you are talking about D1, it will be 1 by 2.5, 1 by 20, 1 by 6, like this. If you are talking about C1, 1 by 6, 1 by 4, there are no conductances over here. And accordingly, the currents, if they are coming out, those will be -6. It is going inside, it will be +2.5. See, here +2.5. And in this case, in case no currents, so in this case it is 0. That one is VAB, right? Sorry, GAB, it is 2.5, GBC is 6. Accordingly, write the equation. Not one thing over here. The thing is, this 2.5, this 15 are taken, this 5 is not taken. If in this case there is an exception, if this 5 is directly connected to the source, we don't take that 5 ohm. Whatever resistance is over there, it can be 5, it can be 100, it can be 1000, it can be 0.2, whatever resistance is given. Okay. 5 ohm is omitted from the equation for node A because it is in series with the current source. Whenever it will be a series with the current source, we have to simply omit the resistance in calculation. Whenever a resistance is just in series with this one, we have to simply omit this one, the resistance. Accordingly, we will get it. Clear? Understood? This is one extension of the shortcut method. Yes, there is nothing more. If you can go through the sums, it will be easy. I will be sending you the total thing over here. Go through solved sums, do the solved sums, both in shortcut method as well as using the
স্যার একটা
KCL.
কোয়েশ্চেন ছিল
Well,
স্যার, এখানে তো আপনি নোডের জন্য ওই 5 ওম রেজিস্ট্যান্সটাকে বাদ দিলেন। আচ্ছা, ওইটা যদি আপনার নোড সি ওই যেখানটা রেজিস্ট্যান্স নেই ওইখানটা থাকতো তাহলেও কি বাদ দিতে হতো?
obviously, সেটাও তো সিরিজে থাকতো.
এখানে তো
If 5 ohm is if the 5 ohm is over here, then also we will omit because the 5 ohm, whatever ohm is this, is in series with this one. Outward, inward এর সঙ্গে series বোঝায়. Series is hand in hand. This is the current source, this is the resistance. It is in series. Whether the current source is this way or this way, that doesn't matter. The resistance is in series with the current source. Simple thing.
ওকে স্যার।
In this case, there is no question of taking the direction of the current. If the 5 ohm is over here also, then we will omit in case of the last equation, that 5 ohm. Simple. বোঝাতে পারলাম কি?
স্যার বুঝতে পারছি।
Any more question you want to ask? একটাই কোয়েশ্চেন স্যার, এটা পাঠিয়ে দেবেন কবে, তাই তো? এটা আমি কালকে সকালে দেখছি, চেষ্টা করবো পাঠানোর। ওকে, ক্লিয়ার?
ওকে স্যার।
Clear or not?
হ্যাঁ স্যার।
হ্যাঁ স্যার।
হ্যাঁ স্যার, ক্লিয়ার।
ফাইন, তাহলে আজকে এই অবধি থাক। ওকে, নেক্সট আমি কবে পড়াবো জানিয়ে দেবো। আমি একটু থাকছি না, আউট অফ স্টেশন। তো তোমাদের যদি খুব কিছু দরকার থাকে তাহলে তোমরা অবভিয়াসলি ফোন করতে পারো, ঠিক আছে? কিন্তু সবসময় যে আমি উত্তর দিতে পারবো তা না, আমি চেষ্টা করবো।
স্যার একটা কথা জিজ্ঞেস করবো আমি?
বল।
স্যার আমি বলছি আমাদের তো ফিজিক্স ক্লাসটা আমাদের কি তাহলে তুমি চলে আসার পর হবে?
হ্যাঁ, সেটা তোদের বলতামই, আমি চলে আসার পর নেবো। কালকে আমি নেওয়ার মতো সময় পাবো বলে মনে হয় না।
না না স্যার ওই জন্যই
ঠিক
জিজ্ঞেস
আছে,
করে
আমি
নিলাম।
সোমবার দিন ফিরবো, সোমবার দিন তোদের ফিজিক্স ক্লাসটা, সেটা
ওকে
আমি
স্যার।
আগে থেকে জানিয়ে দেবো তোকে, অস্মিতাকে আগে থেকে জানিয়ে দেবো কবে। ঠিক আছে, অস্মিতা আছিস তো?
ওকে
হ্যাঁ স্যার।
হুম, আমি জানিয়ে দেবো।
ওকে
সেটা
স্যার।
আমি, আমাকে একটুখানি ইনফ্যাক্ট গ্রুপেই, তোদের গ্রুপটাতে একটু হোয়াটসঅ্যাপ করিস, একটু পিং করিস আমাকে রোববার দিন, ঠিক আছে?
আচ্ছা
তো
স্যার।
আমি
ওকে স্যার।
জানিয়ে দেবো, ঠিক আছে? ওকে
ওকে স্যার।
ওকে দেন। আচ্ছা, আমি আজকে এখানেই শেষ করছি। তোমরা প্র্যাকটিস করো, দেখি দাঁড়া, কতক্ষণ সময়
আচ্ছা
লাগবে
গ্রুপে
দেখি।
অ্যাড
আমি
করে দেবেন আমাকে।
আমি চেষ্টা করছি, হ্যাঁ তোকে অ্যাড করে দেবো, আমি চেষ্টা করছি তোকে পাঠিয়ে দেওয়ার, এই তোদেরকে পাঠিয়ে দেওয়ার এক্ষুনি। আগে করেছিস তোরা এটা, এই মেস অ্যানালিসিস সুপারপজিশন, আমি সলভ এক্সাম্পল সমেত এই নোড অ্যানালিসিসটা পাঠিয়ে দিচ্ছি। পল্লবের কথা মনে পড়ে, স্যার এক্ষুনি পাঠিয়ে দেবেন, কি আর করবো, কষ্ট করে বসি এখন পাঠাই। ঠিক আছে পল্লব?
হ্যাঁ স্যার।
হ্যাঁ স্যার। আচ্ছা, আমি পাঠিয়ে দিচ্ছি, আমি এন্ডিং দ্য ক্লাস ফর টুডে। ওকে, জাস্ট don't just go through the solved sums, just see the problem only and try to solve it. If you stuck anywhere, then see the solution, else don't. Try everything, see whether you have done the right thing or not. If you have done the right thing, you will get the confidence. If you are not doing the right thing, or not in the right way, don't just lose hope. Okay, because seeing just after doing the sums and where you have done the mistake, if you can just find it out, that mistake you will not do again. Just keep it in mind. That is human psychology. So just try to solve the sum by your own, and just see the answers, whether those are correct or not. I'm sending you right now. Just give me 5 minutes. We will send it. Okay, or within today only I will send you. Okay, got it? ঠিক আছে?
হ্যাঁ স্যার।
Okay,
ইয়েস
fine. Okay, end করছি। Okay,
হ্যাঁ স্যার থ্যাংক ইউ।
okay,
হ্যাঁ স্যার, থ্যাংক ইউ স্যার। থ্যাংক ইউ স্যার।
good night.
গুড নাইট স্যার।